Hopefully I'm not just taking them. You will not be taken. That's not creepy at all, Jeff. So I'm taking 22 women, and I want their average bone density to be bigger than 3. I want them to be far away from the average. That should be harder. The answer for part B should be smaller than this. Because when I take a sample, everybody kind of goes towards the middle. It gets skinnier. So my answer should be smaller, should be less likely. We don't have to know that ahead of time, but anyway. So before I do, do you see how the question here is almost the same question? Yes?
We don't have to apply the CLT because...
We are. Definitely have to. I want you to be really careful. When does the CLT come into play? When I take a sample and I ask about the sample mean. The reason I like to do a problem like this, where I just tell you it's normal at first, is because I love to do a problem where you do chapter 6, and then the next part is chapter 7. Because I really like to put it in your face about how little extra work there is for this kind of problem. These are the same question almost. This one is about an individual woman, so I can use this because that's how spread out individual women are. Part B is a question about a group of 22, so can I use this? That's for individual women. I have to make the spread for groups of size 22. How do I do that shit? It's going to be the old one divided by square root of n. All right, keep going. See how far you can get with that. Yes?
Does it have to be over 30?
I love it. You ready? You ready? All right. This is why I put this problem. Were we able to do the first problem, 1A? Did anybody have a problem with doing 1A? You guys were all cool with it. And it only took one person. Why was that okay? Because I told you it already was normal. So either I have to tell you it's normal, or if I don't, what saves your ass? Sample size big enough. So since I told you it's normal, how big does the sample have to be? It has to be whatever the shit it wants to be. I like it. Okay, yes. Yes, exactly. So the fundamental difference between these two questions. This one is about one woman.
Yeah.
So that is for individual women. Beautiful. This one is about a group of 22. I don't know that spread yet.
But it's the same, you're saying like it's the same question.
It's the same format of a question.
Okay.
The work is going to be almost the same. It's just that, am I going to have this number here?
No.
No.
It's going to be 22.
It's going to be, no. Spending whatever the shit this is.
Oh, you have to find
The new standard deviation. I love it. So z-score is always divided by the spread. And on part B, the spread changes. It's like 0.08 something. 0.066. And you can make it 661 if you want to. Remember, it has to be at least 3 places. So now you do the exact same work because the idea of how to get an area doesn't change. It's just how fat or skinny the picture is changes. And that's exactly what we just figured out. It got skinnier. So now I got a group of 22. So now I make a z-score like I always do, but I just better use the right spread. And I look that z-score up, do all the same stuff. So the idea of chapter 7 is not a simple idea, but it does make a very simple change to the work. 1.4. You see these formulas? Almost exactly the same. This one is for individuals, this one is for groups.
And then we just find that once you get the new.
It's exactly what we did here.
Okay.
You find that area, do 1 minus to get that area. It literally is, that's the only difference, is right here. So what do you guys get for this here?
1.51.
1.51? So then if you look that up, you'll get this area. So then you're going to do 1 minus to get that area. Same idea. So this is what I mean by those problems are the same. Structurally, they're exactly the same. There's just one number that changed. But the steps I take, exactly the same. So when I look up 151, what do you guys get?
0.9345.
9345. And then 1 minus that would be 0.0655. So this was 37.5% almost, and now it's only almost 7%. Much less women out there, because when I take a group of 22 women, this picture should become like this now. Because more of the group should be closer to the middle, leaving less out here. That's why that number became smaller, because there's less groups out there. And then 2 is the kind of problem you guys were sort of expecting. I like to do the problem like number 1, but look at number 2. So the life of, these are accurate numbers, by the way. I looked these up. If you're born in California in 2004, I don't think there's any of us, that would be, you're very Doogie Howser-ish, but if you know somebody who was born in California in 2004, their life expectancy, expected values average, so their average lifespan would be 80.2 years. Right? So we're going to freaking save some shit for retirement. You can start working past 75. With a standard deviation of 14.9 years. And then I give you a couple of places where I found the data. I don't know if anybody ever looks those up. If we take a sample of 37 California infants from 2004, I should have been more specific. Why is it okay to use the Z-score chart to find probabilities? Careful. Not mean, but the
Sample.
sample size is bigger than 30. Kick ass. Central limit theorem said no matter how ugly your distribution looked first, if your sample size is more than 30, the simplemans will become normal enough. So part A, why am I allowed to do it? Because central limit theorem says good, n greater than 30.
Do you have to write that out, or do we just do like 37 greater than?
I love it. That's all you got to do. Because that's the why and the what it should be. I love it. And then part B is a problem just like what we did with a group of 22 women. So try to do part B. So part B, I'm just trying to kill these people off early. Oh, sorry. Rune, what else do I have for you? Here. Anybody not get their group quiz back yet? Came in after I... Read. Oh. So when I give you a problem like 2b, very first thing you should do is change that standard deviation. The one they gave me is no good for me. It's dead to me. I got to change it. It goes in here.
37.
Yeah, because that's the sample size. It's crazy. Again, a lot of you guys like to put the mean in there, some kind of decimal in there. They don't make any damn sense. It's got to be a whole number. A number of things. I think once we're done with this one, you guys can do the other ones if you want to, but I'm going to open it up to whatever else you want to look at. Yes?
I have a question. It's just on the last problem. I think I'm doing it wrong. When you're looking for the z-score, isn't it like what's below?
Yes.
So why didn't we put?
So what was the z-score for that last one? It was 1.51? That's the one you're talking
and
about?
then you looked at the area.
1.51, yep.
And it was 0.0655.
No.
No?
Is the z-score negative?
Oh shit, never mind.
Oh shit, okay.
Oh, never
And again, the picture is supposed to help you. You know this area should be big, should be close to 1, because that's a huge chunk of it.
Okay, never mind.
That's all right. Okay. Poor beat up calculator. All right, this one's a little bit freaky. What do you guys get for this standard deviation?
2.45.
Yeah, I get 2.4. Yeah, you can make it 2.45. That's all right. 2.450. I like it. That's the correct way to round to 3 places. You could just do more places if you felt like it. Like, I don't know how to round shit. All right, you should, but oh well. And now the rest of the problem is normal z-score problem. I've made the spread that's correct for the situation. I can now make z-scores using it, do all the same stuff. Nothing else changes. Yes?
Mine came out negative.
That's just the standard deviations, and that's impossible.
I mean, sorry, the z-score.
Oh,
And it is negative.
yeah. That age is above or below the mean, it's below. So the negative is fine.
Okay.
Yep. I haven't made a z-score yet. Is it 75?
Yeah.
Yep. So we want that person to die early. I just want to put it like that. Screw them. This imaginary person in my stats problem die. Now you just make a z-score like normal. You look it up like normal. The beautiful thing is, since this is less than, right? If I remember correctly. Yes. The answer from the chart is it. You're done. So let's see. Z-score would be 75 minus 80.2 divided by 2.45. I get a 2.12? Okay. I like a newsline. How can I say it? Does this guy understand? And then you look it up and you're done. So again, I don't want to say this and make you feel like we went through the whole explanation unnecessarily. You have to understand why that changes. Why does the mean stay the same? So that's what we focused on when I was trying to explain to you. Why does it make sense the standard deviation gets smaller? Why does it make sense the mean stays the same? And then you just love it. You love the fact, okay, that was weird as shit. All that Florida and the picking people and whatever, that was some weird shit. You're like, you just sat there and took it from me. But in the end, the actual nuts and bolts, very simple. You can't use the spread they give you. You got to change it into the spread that works for groups. So again, how did I know to do this? Because I took a sample, and I asked a question about the sample mean. That's how you know when to do that standard deviation formula. That's when central limit theorem kicks in. And again, why did n not have to be bigger? Well, I'm sorry. Why did n have to be bigger than 30 on this one? Because I didn't tell you it was normal, so I needed the sample size to save my ass. Why did it not have to be bigger than 30 in the first one? Because I told you it was normal. It doesn't matter what it is then. All right, so now if you want to, you can do the other ones on there. I'll do those in a little bit, but I want to just open it up because the test is going to be about more than just chapter 7, so we can do any of the questions you got. I'm going to give out the answer key in a bit.
The practice test?
Sure.
Go over
All of it? Do you have anything specific or? So, all right. So if I were a student taking a test, and this is what I always did. Not always, but it took me a while to figure this out, but I would go through it, and I'm like, number one, I'm like, I don't have a flipping clue how to do that shit. I would go through, find something I know and understand, and I can do it. Because sometimes the reason you're not sure what to do is a lack of confidence, and if you get something done, your confidence goes up a tick. And then maybe you're able to handle something else you weren't able to before. So I used to have a friend that sat next to me we're still friends, but way back when in physics class, and she would have to do the test. She couldn't do number 2 until she got number 1 done. And I'm like, Sue, you gotta, holy shit. So hopefully, if you are like that, I am sorry. You've got to break through that shit. Because trust me, I would always do them out of order. Because there's something that makes more sense, and if I build up some confidence, I'm able to handle something else. And I build up more confidence, and you continue. So if that happens to you, doesn't mean you're stupid or bad or anything. It just means that's the way things happen. Yes?
Is number 5, is also the probability?
Yes.
Are we not doing that? Or are we not doing percentile? Wait, are we not doing probability or percentile?
So number 5, what kind of problem is number 5? Can you identify the type of problem it is? I gave you a percentage who think that they are reliable. So that's the probability somebody thinks it is reliable, so there must be a probability that somebody thinks it isn't. There's 2 things, and then I gave you a total number of people, 24 is n. So that's an NPQ problem. So in that case, if I ask you a probability question for that, you're going to use what formula? The choose. Because that's the probability formula for NPQ. And how do you know that? Because on your formula sheet, you got a P of X, which is probability, and you got a formula with a bunch of N's, P's, and Q's in it. Now see, it kind of hurts me a little bit to say that, but you've gone through the whole explanation of why the formula is, so now I'm okay with just saying, hey, you got N's, P's, and Q's. Find a formula that's got N's, P's, and Q's in it if you're not sure what the hell to do. But so number 5, do you see the look of that? You should notice things about it that tell you it's an NPQ problem. And that is a big part of this, is identifying the kind of problem it is. Number 1, I'm hoping, might be the most straightforward question on this test. Because there's only one set of options for it. I give you X's and P of X's. I give you 2 blank columns, which is me being really nice. Trying to remind you there's a couple things you have to calculate, right? So number 1 is going to be using the sum of x p of x and the sum of x squared p of x minus mu squared and blah, blah, blah. Now remember that the formula I put up there was sigma squared, was the variance, is the sum of x squared p of x minus, and then you have to take the square root. So a lot of you guys forget to take the square root. So don't forget. Yes?
Wait, did number 3?
Yeah, number 3 is a little bit funkadelic. Shit. The first part of number 3, I'm hoping isn't too weird. It's the second part that's a little weird. So I'm gonna call it 3A. What's it say? I want a normal curve, and I want to find a z-score that has 91% below it. So can you first just draw that situation? I kind of love, there's a special place in my heart for the person that does this. Holy shit. That's like taking the whole state of, the whole country and putting every American into Vermont. It's like, okay. No. Don't shove 91% in there. Where's it got to be?
Right.
It's got to be up here so there's room for all the 91%. So I already know that the z-score is going to be positive or negative? Positive. So how do you find that z-score? No? Use the chart. What converts z-scores to probabilities and vice versa? The chart. That's what its job is. So do not look up 0.91. It's not a z-score, right? It's an area. So you try to find as close as you can to 0.91. And there should be something really, 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 really close.
1.2.
Yeah, you get where'd it go? 9099. You guys see that? 9099. That's damn close. What's z-scores 9099? 1.34. That problem is done. If I remember right. Yeah, all I wanted was a z-score. Now, that's part A. Part A should be really straightforward. It's just looking up in the body and finding a z-score instead of the other way around. Can you draw part B? So now it's supposed to be the middle 91%. Not the top, not the bottom, but the middle. And see what I just did? Middle, right? So that's going to be like this. Bookends. If this was -2, this one would have to be, yeah, symmetric. So if I find one of them, I basically have the other one. I just change the sign. Does the chart understand this area at all? No. That's a dumb thing. It's a piece of paper. Holy shit. It only understands areas that are below. I have two z-scores. I can get either one of them and I know the other one. So what's the area, for example, below this z-score that I want? Beautiful, because if there's 91% inside, there is 9% outside, there is 4.5% on that side. So yeah, you do have to do a little work. But why are we doing that work? Because the chart only understands areas below a z-score that I want. Here's the z-score I want. Can I figure out what the area is below it? Yeah. And then I can look that up. So 0.045. Does everybody see where that came from? Like, yeah, you wrote it, Jeff. No, but... And now you look that up and get as close as you can. That problem is a problem we can do right now, obviously, because I am going to have that kind of problem on the test. I guarantee it. Because it's getting us ready for what's coming in the next chapter after this test. Oh, shit. So again?
Where did you find 0.045?
I didn't find it anywhere. So if there's 91% inside, what percentage is outside? 91% in. 9. So what percentage is on that side?
Okay.
4.5. Just cut it in half. What's the closest you can get to 0.045?
0401.
Do it again.
0401.
Oh, 0.0401. You can get closer to 0.045 than that, right?
Negative 1.7.
Yeah, I get 0.0446. You guys see that? Or 0.0455, but 0.0446 is a little bit closer. So you use negative 1.70. If this is negative 1.70, this one is done. You found the two z-scores bounding the middle 91%.
You do 4B.
Oh yeah, I love. Yeah, I'm sorry. I gotta stop saying that. I love all these problems. Yes.
Which way would we shade in for 3A?
Oh, this. But I didn't really shade it. I just put it there. I don't really need the shading because I know where it is. When I shade for problem, it's just reminding me what the answer will be. So if I haven't gotten that yet, that 0.91, I know it's there. You know what I mean? So you could shade it if you want to. It doesn't really matter.
So we don't have to shade it.
So again, if I have a problem like the problem like z greater than 1, the shading is done just to remind me that if I get this, I'm not done yet. Here I know 91's below. I don't really have to shade it. It doesn't really help. But you could if you wanted to. It's not going to change anything. Okay.
4B.
4b. Do you see how that relates to 4a1? So let me ask you this. If I knew that 80% of students of them scored higher than, I don't know, what makes sense? It doesn't really matter, Jeff. Scored higher than 200, right? You with me? And I have 5,000 students. How many of them would score higher than 200? 80% of 5,000, right? Okay. So that's not what 4b says, right? 4b, but it's the same idea. 4b says I got 2,000 students. What's the number of them that will score more than 302? So why could I do this problem? Because I knew the percentage to take of 5,000. So here, what percentage do I take of 2,000? Your answer to 4-1A. What is the percentage that scored greater than 302? What is this? Well, that's exactly what you calculate in part A above, right? Right? Isn't that the first problem in 401A? Isn't that what it makes you do? Figure out the probability or the percentage above 302. So part B is just me showing you that once you get an answer to this, like we do for chapter 6 all frickin' day long, I could use it to do more shit. It doesn't just get circled and forgotten about. You can actually use it like any percentage. Yes?
So, part 1 is, or 4-1 is the probability, and then 4B is the number of actual students.
Yeah, so when you do 4A1, you could call it a probability, but what's a slightly better way to say it? It's a percentage of students who scored greater than 302. So you're going to actually figure out the percentage of students. So then if I give you a number of students, you can figure out how many because you take that percentage. So did anybody do 4-1A? Yeah, it sounds right. 27 what? 2743, yeah. So 27.43% of students scored higher than 302. Okay, well, if I had 2,000 students, how many would I expect to score more than 302? That percentage of this. That times this. We know that. If I make 80% of my free throws and I take 20 free throws, how many do you expect me to make? 80% of 20. Yes? What time? I'll give out the answer key in a minute. Okay, good. This is perfect. That's right. I meant to come to this earlier and I totally forgot. So, now that hopefully we understand central limit theorem a little bit better. So everybody got what they want from this here. I'm going to give you the answer key in a minute anyway. We got to do 6D first. So this is a uniform distribution from 2 to 8, right? So the mean is this, which should hopefully just make sense. You have to do this in the homework in a few places. And the standard deviation is this freaky ass thing. You guys alright? So you just throw stuff in. And again, I told you, this will not show up on the test. Does that mean it has no importance in life? No. I love you guys. Don't humor me, I love it. But of course this is important. You're supposed to have a way to figure out these two because it's the most important thing, but in this case it's not like extra important. So, but I can do this. It would be 8 minus 2 squared divided by 12. It's like 1.7 something. 1.732? All right, so that's part D of number 6. Just calculate the mean and standard deviation. Why is that not evil? Because it's a frickin' practice test. You can just look those formulas up. Who cares? Part E says, the very first thing part E says is I take a sample, right, I guess the second thing, a sample of 43. What changes? Yes. So I take the thing I just calculated and I modify it. Because what is this good for? Absolutely not. No. This is good for individuals. I need the one that works for groups of 43. So the point I have with number 6 is that I don't give a shit where sigma came from, how it calculated, if somebody just told it to me. If I take a sample